Assalamu alaikum. Welcome to lecture number 21 of the course on statistics and probability. Students, you will recall that in the last lecture I discussed with you the addition theorem and the multiplication theorem. And in the discussion of the multiplication theorem, we utilized the concept of conditional probability. In today's lecture, I will present to you the special case of the multiplication theorem for the case of independent events, and towards the end of the lecture, I will discuss with you an important theorem called the Bayes theorem. Before we begin the discussion of independent events, students, let us revise the concepts that we did in the last lecture by way of a very interesting example. और जैसा कि आम फीलिंग है कि probability तो बहुत ही मुश्किल चीज़ है, हो सकता है कि आपको ये एग्जाम्पल थोड़ा सा ट्रिकी लगे, लेकिन जैसे मैं आपसे पहले कई दफ़ा कह चुकी हूँ, all you need is a methodological approach. As you now see on the screen, suppose that a bag contains 10 white and 3 black balls. Also, another bag contains 3 white and 5 black balls. Suppose that 2 balls are transferred from the first bag and placed into the second one, and then 1 ball is taken from the second bag. What is the probability that the ball drawn from the second bag is a white ball? In order to answer this question, let us first consider the situation that we have in the beginning of the experiment. In the beginning of the experiment, we have 10 white and 3 black balls in the first bag and 3 white and 5 black balls in the second bag. Now, let A represent the event that 2 balls are drawn from the first bag and transferred to the second bag. Then, A can occur in the following 3 mutually exclusive ways. A1, the first way is that 2 white balls are transferred from the first bag to the second one. A2, the second way is that 1 white ball and 1 black ball are transferred from the first bag to the second one. And A3, the third and last way of doing this, of transferring 2 balls, is that 2 black balls are transferred from the first bag to the second one. Students, ये मैंने क्यों कहा कि ये जो तीनों तरीके हैं, they are mutually exclusive. आपको याद होगा कि mutually exclusive का मतलब है the events which exclude each other. वो events जो बैक वक्त नहीं हो सकते, अगर एक हो रहा है तो दूसरे नहीं हो रहे, और जाहिर है कि इस प्रॉब्लम में ये तीनों बातें एक ही वक्त में नहीं हो सकती. या दोनों वाइट बॉल ट्रांसफर होंगे, या एक वाइट और एक ब्लैक ट्रांसफर होगा, और या दोनों के दोनों ब्लैक ट्रांसफर होंगे. तो एक वक्त में इन तीनों में से एक ही बात हो सकती है, एंड देयरफॉर वी से दैट दीज 3 ways of transferring 2 balls are mutually exclusive. अब अगला क्वेश्चन ये है कि इन तीनों तरीकों से जो ट्रांसफर है, ऐसा करने के कितने तरीके हैं. इसलिए कि आपको याद है ना कि पहले बैग में सिर्फ 2 बॉल या 3 बॉल तो नहीं है ना, बहुत सारे बॉल हैं. सो एज यू नाउ सी ऑन द स्क्रीन, द टोटल नंबर ऑफ वेज इन विच 2 white balls can be drawn out of 10 white balls is 10C2, because as indicated in the last lecture, the rule of combinations is to be applied in this kind of a situation. Also, the total number of ways in which two balls can be drawn out of a total of 13 balls is 13C2. And dividing 10C2 by 13C2, we obtain the probability of A1, that is, the probability that two white balls are transferred from the first bag into the second one. Solving this expression, the probability of A1 comes out to be 45 by 78. In a similar way, we can compute the probability of the event A2, that is, that one white ball and one black ball are transferred from the first bag into the second one. Now, in this case, the total number of ways of drawing two balls out of 13 is 13C2, just as before, and this expression occurs in the denominator of the formula of probability. But the numerator is obviously different, and in this case, it is 10C1 into 3C1. ये मैंने क्यों कहा कि न्यूमरेटर जो है that will be 10C1 into 3C1. Students, आपको एक white ball draw करना है out of 10 and आपको एक black ball draw करना है out of 3. So 10C1 ways of drawing one white ball out of 10 white balls and 3C1 ways of drawing one black ball out of 3 black balls. और चूंकि इन दोनों बातों के दरमियान and का लफ्ज इस्तेमाल किया जा रहा है, लिहाजा we will multiply that first expression with the second one. After all, do you not remember that example that we did in an earlier lecture, that, for example, if you have 3 ways of ordering a soup and 2 ways of ordering a sandwich, then the total number of ways of ordering your lunch is 3 into 2. वहाँ भी तो आपने मल्टीप्लाई ही किया था ना. और आपको याद है कि लास्ट लेक्चर के एंड में भी मैंने आपको यही बात स्ट्रेस की थी कि जब भी एंड का लफ्ज आए तो आप मल्टीप्लिकेशन के बारे में सोचिए. Dividing 10C1 into 3C1 by 13C2, the probability of A2 comes out to be 30 by 78. In a similar way, the probability of the event A3, that is, 2 black balls transferred from the first bag into the second, is given by 3C2 divided by 13C2, and that is 3 by 78. I hope that you are realizing that the definition that I have applied in computing these probabilities is the classical definition of probability. याद है ना कि जब भी आपके various outcomes equally likely हों, then you are in a position to apply the classical definition. यहाँ पे वो जो बैग है उसमें से हम जो बॉल ड्रॉ कर रहे हैं, we are doing it without looking into the bag. We are doing it in a random manner. और जब कभी आप random sampling करते हैं इस तरीके से, then of course the various elements of your population are equally likely to be drawn. Now, after having transferred 2 balls from the first bag, what happens to the second bag? This is a very, very important question, and we have to analyze it one by one. In the first situation, if 2 white balls are transferred, students, then in our second bag, we now have 3 plus 2 equal to 5 white balls, and as before, 5 black balls, and now the total number of balls in that bag is not 8 but 10. Under this situation, the probability that a white ball is drawn out of the second bag is given by 5/10 because there are 5 white balls in the bag at this time. This probability is denoted by P of W given A1, and as you can see, it is a conditional probability. ये इसलिए कि ये जो आंसर हमने ऑब्टेन किया है 5/10, this is under the condition that 2 white balls have been transferred into the second bag. In other words, it is under the condition that the event A1 has already occurred. The second situation is that 1 white and 1 black ball is transferred from the first bag into the second one. And if this is the case, then the second bag contains 3 plus 1 equal to 4 white balls and 5 plus 1 equal to 4 black balls. Also, the total number of balls in the bag is 8 plus 2 equal to 10. Hence, the probability of obtaining a white ball from the bag number 2 in this particular situation is 4/10. And once again, this is a conditional probability because the probability of getting a white ball in this situation is being computed under the condition that 1 white and 1 black ball have been transferred into this bag. In other words, this probability is being computed under the condition that the event A2 has already occurred. In a similar way, we can compute the probability of W given A3, that is, that we draw a white ball from the second bag under the condition that 2 black balls had been transferred into the second bag. In this situation, we have 3 white and 5 plus 2 equal to 7 black balls in the second bag, and the total number of balls now is 10. Hence, the probability of getting a white ball from the second bag, given that 2 black balls had been transferred into that bag, is equal to m over n, favorable over the total number of outcomes, and that is 3/10. Students, आपको याद है कि इस प्रॉब्लम में क्वेश्चन क्या था? इतना लंबा प्रॉब्लम है कि क्वेश्चन ही याद नहीं रहा. क्वेश्चन ये था कि what is the probability that after this transferring has happened, if we draw 1 ball from the second bag, it is going to be white? तो हमने ये जो मुख्तलिफ पॉसिबिलिटीज हैं इनको तो कंसिडर कर लिया, लेकिन ओवरऑल प्रोबेबिलिटी निकालने के लिए वी विल बी अप्लाइंग द स्पेशल केस ऑफ द एडिशन थ्योरम. आपको याद है ना कि स्पेशल केस ऑफ द एडिशन थ्योरम ये था कि if A and B are mutually exclusive events, then the probability of A union B is equal to the probability of A plus the probability of B. और जाहिर है कि अगर 2 से ज़्यादा इवेंट्स होंगे तो हम इस थ्योरम को एक्सटेंड कर लेंगे. Probability of A union B union C is equal to probability of A plus the probability of B plus the probability of C. तो इस प्रॉब्लम में A, B और C कौन से 3 म्यूचुअली एक्सक्लूसिव इवेंट्स हैं? वही जिनका जिक्र हमने शुरू में किया था. Either 2 white balls are transferred, or 1 white and 1 black, or 2 black. So, the probability of obtaining a white ball is equal to the probability of this first situation plus the probability of the second situation plus the probability of the third situation. And as you now see on the screen, mathematically speaking, the probability of a white ball is equal to probability of A1 intersection W plus the probability of A2 intersection W plus the probability of A3 intersection W. Probability of A1 intersection W means the probability that the event A1 occurs and a white ball is drawn from the second bag. And according to the general multiplication theorem of probability, probability of A1 intersection W is equal to probability of A1 into probability of W given A1. Substituting the values 45/78 and 5/10 in this formula, probability of in A1 intersection W comes out to be 15/52. In a similar way, probability of A2 intersection W comes out to be 8/52, and the probability of A3 intersection W comes out to be 3/260. Hence, the required probability is probability of W equal to 15/52 plus 8/52 plus 3/260, and that is equal to 0.45. In other words, the chances are 45% that if two balls are transferred from the first bag into the second one, and then a ball is drawn from the second bag, this ball is white. तो देखा आपने, this is the methodological way in which you attempt probability problems. अगर आप उसके एक एक हिस्से को अलग अलग कंसिडर करें और बाद में उन्हें प्रॉपरली कंबाइन कर दें, तो you should be able to arrive at the correct answer. All right, let us now proceed to the concept of independent events. As you now see on the screen, two events A and B in the same sample space S are defined to be independent or statistically independent if the probability that one event occurs is not affected by whether or not the other event has occurred. In other words, if probability of A given B is equal to probability of A and probability of B given A is equal to probability of B, then we say that the events A and B are statistically independent. आइए अब मैं इस पॉइंट को एक्सप्लेन करती हूँ कि हमने ये क्यों कहा कि if probability of B given A is equal to the probability of B, then A and B are independent. देखिए स्टूडेंट्स, probability of B given A का मतलब है the probability that B occurs given that A has already occurred. और probability of B, अगर हम सिर्फ probability of B कहें तो इसका मतलब है the probability that B occurs और उसके अंदर A का कोई ताल्लुक नहीं है, यानी it simply means the probability that B occurs regardless of whether or not A has occurred. तो फिर ये जो equation, ये जो statement हमने दी that if P of B given A is equal to P of B, then A and B are independent, इसको हम इस तरह state कर सकते हैं कि if the probability that B occurs given that A has already occurred is the same as the probability that B occurs regardless of whether or not A has occurred, then A and B are independent. तो अगर आप गौर करें तो ये तो intuitively acceptable है. अगर आम लाइफ से आप इंडिपेंडेंस का कॉन्सेप्ट उठाएं तो यही बनता है ना कि एक चीज का दूसरे के साथ कोई ताल्लुक नहीं. तो जब हम ये कहें कि जी ए अकर होने पर बी की क्या प्रोबेबिलिटी है, वो वही है कि जो चाहे ए अकर हुआ या ना हुआ, जो बी की प्रोबेबिलिटी है। तो फिर इसका मतलब है कि ए के अकर होने या ना होने से बी की प्रोबेबिलिटी पे कोई असर नहीं पड़ रहा। एंड दिस इज एग्जैक्टली द कॉन्सेप्ट ऑफ स्टैटिस्टिकल इंडिपेंडेंस। मेरा ख्याल है कि आप कुछ कंफ्यूज ही हो रहे हैं। ऐसा बिल्कुल कोई मामला नहीं है स्टूडेंट्स। लेट मी एक्सप्लेन इट टू यू with the help of a very simple example. Suppose that I have a die in my right hand and a coin in my left hand. Die भी बिल्कुल perfect है, सही बना हुआ है, और coin भी बिल्कुल सही है. So, the classical definition applies. All 6 outcomes on the die are equally likely to occur, and both the outcomes of the coin are also equally likely to occur. Now, if I toss the two, right hand से मैं die को toss कर दूं और left hand से coin को, तो क्या आप agree नहीं करेंगे कि die के ऊपर जो भी event हो रहा है उसका coin वाले के साथ कोई ताल्लुक नहीं है किसी किस्म का। उसके ऊपर चाहे even नंबर आ रहा हो या odd नंबर आ रहा हो, इधर head या tail आए, आपस में तो उनका कोई ताल्लुक नहीं है ना। This head cannot affect this even number, and this even number cannot affect the outcome of the coin. So, coin के ऊपर head आए या ना आए, this does not affect the probability of getting an even number on the die. In other words, the probability of B given A is equal to the probability of B, regardless of whether or not A has occurred. Students, because of this fact that I have just conveyed to you, the multiplication theorem takes a special form, as you now see on the screen. If A and B are independent, then probability of A intersection B is equal to probability of A into probability of B. The reason is very simple. If we substitute P of B given A equal to P of B in the original multiplication theorem, we obtain this simple form that I just mentioned. यहाँ पे एक बड़ी इंटरेस्टिंग बात सामने आ रही है। अक्सर देखा गया है कि स्टूडेंट्स जो हैं वो म्यूचुअली एक्सक्लूसिव और इंडिपेंडेंट इन दोनों कॉन्सेप्ट्स को मिक्स कर देते हैं। हालांकि अगर आप गौर करें तो they are very different. In fact, two events which are mutually exclusive, they cannot be independent. You see, mutually exclusive means that if one event occurs, the other cannot occur. तो उनमें तो एक ताल्लुक है। ताल्लुक ये है कि एक अगर हो रहा है तो दूसरा नहीं हो सकता, जबकि इंडिपेंडेंट का तो मतलब ये बन रहा है कि कोई ताल्लुक ही नहीं। सो द टू कॉन्सेप्ट्स मस्ट नॉट बी मिक्स्ड। जैसा कि मैंने कहा, म्यूचुअली एक्सक्लूसिव का मतलब है कि दे कैनॉट अकर टुगेदर। उनका आपस में एक रिपल्शन का ताल्लुक है। दे आर रिपेलिंग ईच अदर। और यहाँ पे मुझे वो खूबसूरत शेर याद आ रहा है, लाग हो तो उसको हम समझें लगाओ, लाग हो तो उसको हम समझें लगाओ, जब न हो कुछ भी तो धोखा खाएं क्या। इंडिपेंडेंट तो वो हैं कि जहां कोई ताल्लुक नहीं है। सो स्टूडेंट्स, द टू कॉन्सेप्ट्स मस्ट नेवर बी मिक्स्ड। द इक्वेशन दैट आई प्रेजेंटेड टू यू, probability of A intersection B is equal to probability of A into the probability of B if A and B are independent. Let us apply this to an example. As you now see on the screen, two fair dice, one red and one green, are tossed. Let A denote the event that the red die shows an even number, and let B denote the event that the green die shows a 5 or a 6. Show that the events A and B are independent. In order to solve this question, students, हमें 3 quantities compute करनी है. Probability of A, probability of B, and probability of the joint event A intersection B. और अगर probability of A intersection B, probability of A into probability of B के बराबर आ जाए, that is, the left hand side comes out to be equal to the right hand side, then of course we can say that A and B are independent. So, in order to compute these 3 probabilities, how do we proceed? A is the event that the red die shows an even number. तो even number की probability क्या हो सकती है? Obviously 3/6, because there are 6 possible outcomes, 1, 2, 3, 4, 5, 6, and there are 3 even numbers, 2, 4, and 6. इसी तरह B is the event that the green die shows a 5 or a 6. And what is the probability of B? Obviously 2/6. ये तो आसान है. But how do we compute the probability of the joint event A intersection B? The event that the red die shows an even number and a green die shows a 5 or a 6? Students, for that we will have to consider the sample space of the joint situation, and as you now see on the screen, the sample space consists of the 36 possible outcomes 1, 1, 1, 2, 1, 3, 1, 4, and so on up to 6, 6. Now, it is obvious that the total number of possible outcomes for the joint experiment is 36. But how do we determine the number of outcomes that are favoring the joint event A intersection B? If you look carefully, you find that there are 6 outcomes which favor this joint event, and they are 2, 5, 4, 5, 6, 5, 2, 6, 4, 6, and 6, 6. The reason is that the first number represents the outcome on the red die, whereas the second number represents the outcome on the green die. Dividing the number of outcomes favoring this joint event by the total number of possible outcomes, we obtain probability of A intersection B is equal to 6/36, and that is 1/6. हमारे multiplication theorem की equation क्या थी? Probability of A intersection B is equal to probability of A into the probability of B in the case of independent events. तो इस equation की left hand side तो हमने determine कर ली, उसकी numerical value 6/36 या 1/6. Now, what about the right hand side? We have to compute probability of A into the probability of B, and it comes out to be 3/6 into 2/6, that is 6/36 or 1/6. Hence, the equation is validated and we say that the events A and B are independent. यानी हमने mathematically ये show कर दिया that the two events are independent. लेकिन अगर आप उस पहली बात पे जाएं, एक हाथ में red die, दूसरे हाथ में सब्ज़, उन्हें आप फेंकें, जाहिर है कि whatever is happening on the red die does not affect what is happening on the green one. Let us now extend the concept of independent events to the case of more than 2 events. Students, 3 events A, B, and C, all defined on the same sample space, are said to be mutually independent if they satisfy the following conditions. Number 1, they should be pairwise independent, that is, probability of A intersection B is equal to probability of A into probability of B. probability of A intersection C is equal to probability of A into probability of C, and a similar equation for B and C. The second condition is that A, B and C should be mutually independent. That is, the probability of A intersection B intersection C should be equal to probability of A into probability of B into probability of C. Let me explain this to you with the help of an example. Suppose that a coin, a red die and a blue die are tossed together. Let A denote the event that the coin shows head. Let B denote the event that the red die shows an even number. And let C denote the event that the blue die shows a 6. We would like to show that the events A, B and C are statistically independent. Now, students, in order to solve this problem, first of all, let us consider the three events A, B and C separately. Assuming that the coin and the two dice are fair, we have probability of A is equal to 1 by 2, probability of B is equal to 3 by 6, and probability of C is equal to 1 by 6. This is so because A represents a head, B represents an even number, and C represents a 6 on the die. Next, let us consider the joint events A intersection B, A intersection C, and B intersection C. Students, when the coin and the red die are tossed together, our sample space will consist of 12 outcomes, that is H1, H2, H3, and so on up to T6. Out of these, 3 ordered pairs favor the event A intersection B. That is, the event that we obtain a head on the coin and an even number on the red die. और ये 3 ordered pairs कौन से हैं? H2, H4 and H6. Hence, the probability of A intersection B is equal to 3 by 12. Similarly, when the coin and the blue die are tossed together, our sample space once again consists of 12 outcomes, H1, H2, and so on. Now, out of these, 1 ordered pair favors the event A intersection C. That is, the event that we obtain a head on the coin and a 6 on the red die. और जाहिर है कि ये ordered pair वही है जो H6 पढ़ा जाएगा. Hence, students, the probability of A intersection C is 1 over 12 because we have 1 outcome favoring this particular event out of 12 possible outcomes. Students, when the red die and the blue die are tossed together, our sample space consists of 36 ordered pairs, which are 1, 1, 1, 2, 1, 3, and so on. Now, out of these, 3 ordered pairs favor the event B intersection C. That is, the event that we obtain an even number on the red die and a 6 on the blue die. और ये 3 ordered pair कौन से हैं? 2, 6, 4, 6 and 6, 6. Hence, the probability of B intersection C is 3 by 36. Thirdly, students, let us consider the tossing of the coin and the 2 dice together. Now, if they are being tossed together, then according to the rule of multiplication, our sample space consists of 2 into 6 into 6, that is 72 possible outcomes, and these are 72 ordered triplets of the form H11, H12, H13 and so on, and students, the second last one will read T65 and the last one T66. Out of these 72 possible outcomes, only 3 favor the event head and even number, and these 3 are H26, H46 and H66. Hence, the probability of the joint event head and even number and 6, that is, the probability of A intersection B intersection C, is given by 3 by 72. Students, in order to verify that the events A, B and C are mutually independent, we will be substituting all the above computed probabilities in the equations that were presented earlier, and we will be noticing that the left hand side will be coming out to be equal to the right hand side. First of all, in order to determine whether or not A, B and C are pairwise independent, we would like to check whether or not the equation probability of A intersection B is equal to probability of A into probability of B is verified numerically. Students, as you can see, both sides of this equation are numerically equal to 1 over 4, and hence this particular equation is verified. Similarly, probability of A intersection C is 1 over 12 and probability of A into probability of C also comes out to be 1 over 12, and hence this particular equation is also verified. And as you now see on the screen, a similar situation holds for B and C. Hence, we conclude that the events A, B and C are pairwise independent. Now, in order to verify the second condition, we note that probability of A into probability of B into probability of C comes out to be 3 over 72, exactly the same as what we obtained for probability of A intersection B intersection C. Hence, this particular equation is also verified, and students, since both the conditions of independence are fulfilled, therefore, we can conclude that in this particular experiment, the events A, B and C are statistically independent. In general, K events A1, A2, so on up to AK will be defined to be mutually independent if and only if the probability of the intersection of any 2, 3, so on up to K of them equals the product of their respective probabilities. So, this is the concept of independence. Technically speaking, once again, the two events A and B are statistically independent if the probability of A intersection B is equal to the probability of A into the probability of B. Students, let us go back to that very interesting example that we considered in the last lecture, the births that are occurring in various regions of England and Wales. And as you remember, we were talking about the sex of the baby and whether it was live born or stillborn. As you now see on the screen, the data was that out of a total of 7,16,740 births in 1956 in that region of the world, there were 3,59,881 live-born male babies, 8,609 stillborn male babies, and so on. And the corresponding proportions were male live-born 0.5021, male stillborn 0.0120, female live-born 0.4750, and female stillborn 0.0109. As you will remember, the total number of births in this data set is large enough for us to regard these proportions as probabilities, according to the relative frequency definition of probability. तो अगर इस प्रॉब्लम में हम इस बात इंटरेस्टेड हों कि हम डिटरमिन करें whether the sex of the baby and the nature of birth are they independent or are they dependent, तो हम किस तरह से प्रोसीड करेंगे? Students, we have two options. Either we look at the equation, probability of B given A is equal to the probability of B, or we look at the equation, probability of A intersection B is equal to probability of A into probability of B. ये जो सेकेंड इक्वेशन है, ये तो हमने काफ़ी डिटेल में अभी डिस्कस की. इस प्रॉब्लम में लेट मी लुक एट द फर्स्ट इक्वेशन. जब हमने डिफाइन किया था इंडिपेंडेंट इवेंट्स को, तो यही कहा था ना कि if the conditional probability is the same as the unconditional probability, then the two are independent. तो देखते हैं कि इस प्रॉब्लम में क्या ये इक्वेशन होल्ड होती है. As you now see on the screen, the total number of male births is 3,68,490. And the babies who were stillborn among these 3,68,490 were 8,609. So, the probability of stillbirth, given that it is a male baby, is equal to 8609 over 368,490, and that is equal to 0.0234. On the other hand, the total number of female births is 3,48,250, and the number of stillbirths among the female babies is 7,796. So, the probability of stillbirth, given that it is a female baby, is equal to 7796 over 348250, and that is 0.0224. ये तो हुई conditional probabilities. And what is the unconditional probability of stillbirth? In all, there are 7,16,740 births, out of which 16,405 are stillbirths. So, the probability of stillbirth without any condition of the sex of the baby is 16405 divided by 716740, and that is 0.0229. Students, आइए अब इस सिचुएशन को एनालाइज करते हैं. आपने देखा कि जो अनकंडीशनल प्रोबेबिलिटी है दैट इज 0.0229, लेकिन जो कंडीशनल प्रोबेबिलिटी थी फॉर द मेल बेबीज कि अगर वो मेल बेबी है तो फिर स्टिल बर्थ की प्रोबेबिलिटी क्या है, यू रिमेंबर it was 0.0234, and that is slightly higher than 0.0229. इसी तरह जो conditional probability थी for the female babies, that was 0.0224, which is slightly lower than 0.0229. तो फिर इससे हम क्या conclusion draw कर सकते हैं? That the probability of stillbirth in males is slightly higher than the overall unconditional probability of stillbirth, whereas the probability of stillbirth in females is slightly lower. Hence, we cannot say that stillbirth and sex are statistically independent. इसलिए कि independent तो वो तब होते ना if the probability of stillbirth given male was exactly equal to the unconditional probability of stillbirth and the probability of stillbirth given female also exactly equal to the unconditional probability of stillbirth. So, the gist of the whole discussion is that in this problem, we cannot say that the gender of the baby and the nature of birth are statistically independent. In fact, we should realize that among the babies who are still to be born, the male baby is at a slightly higher risk of being stillborn as compared with the female baby. Students, the table that you saw in this example leads to another important concept in probability theory, and that is the concept of marginal probabilities. As you now see on the screen, we have the bivariate table and we have the 4 joint events: male live-born, male stillborn, female live-born and female stillborn. But the probabilities that I am pointing to now are the ones that occur in the margins of this table. I am referring to the last column of the table as well as the last row of the table. Considering the column, the first marginal probability is 0.5141 and the second one 0.4859. And what do these represent? The first one is the probability that the baby is a male, whereas the second one is the probability that the baby is a female. If we look at the last row of the table, the first probability 0.9771 is the probability that a baby is live-born, whereas the second marginal probability 0.0229 is the probability that a baby is stillborn. The point to realize is that when we talk about marginal probabilities, we are only talking about one of the 2 variables that we have in front of us. When we say that the probability of a male birth is 0.5141, we are saying this regardless of whether it is a live birth or a stillbirth. The event male birth in this problem can happen in 2 ways. Either it's a male birth and a live birth, or it's a male birth but a stillbirth. So, the probability of a male birth is equal to the probability of male intersection live birth or male intersection stillbirth, and that is equal to the probability of male intersection live birth union male intersection stillbirth, and this is equal to the probability of male intersection live birth plus the probability of male intersection stillbirth. This is equal to 0.5021 plus 0.0120, and that is 0.5141. Hence, we realize the very important relation between the joint probabilities and the marginal probabilities, and that is that in any row or any column, the sum of the joint probabilities is equal to the corresponding marginal probability. Another very important equation is that conditional probability is equal to joint probability over marginal probability. In this example, the probability that it is a stillbirth, given that it is a male birth, is equal to the probability of the joint event, that it is the male birth and the stillbirth, divided by the probability of male birth. And this is totally in accordance with the formula of conditional probability that I conveyed to you in the last lecture. Probability of B given A is equal to probability of A intersection B divided by the probability of A. Substituting the numerical values of these probabilities, we obtain probability of stillbirth given male birth equal to 0.0233. And in a similar way, we can compute other conditional probabilities. In today's lecture, we discussed the concept of independent events, and we studied the special case of the multiplication theorem in the case of independent events. Also, we considered the concept of marginal probability. और इन सबसे पहले हमने वो interesting example किया जिसमें 2 balls are transferred from the first bag into the second and then a ball is drawn from the second. उस example को इतनी डिटेल में करने का मकसद ये था कि आप में एक कॉन्फिडेंस डेवलप हो कि अगर आप एक मेथोडोलॉजिकल तरीके से किसी भी प्रोबेबिलिटी प्रॉब्लम को अप्रोच करें तो आप उसको टैकल कर सकते हैं. आप सिंपली उस प्रोबेबिलिटी से शुरू कीजिए विच इज़ द रिक्वायर्ड प्रोबेबिलिटी, और उसके बाद देखिए कि व्हाट आर द डिफरेंट वेज इन विच that particular event can happen. I would like to encourage you, students, to shed off your fear of probability theory and to try to attempt as many questions as you can. The more you practice, the better off you will be. I wish you the very best in your pursuit of knowledge in this area, and until next time, Allah Hafiz.